Fusion Mobile, quality e-learning experience on the go.
Refraction of light waves at plane surfaces. First, we'll discuss refraction. Refraction is the change in direction of light rays when light travels from a transparent medium to another transparent medium of different densities. It can be said to be the change in direction of light rays when light travels through transparent media, through the boundary of transparent media through the boundary of two transparent media of different densities. Now we want to take a consideration of real depth, apparent depth, and refractive index. That brings us to the law of refraction. The law of refraction, the first one states that the incident ray, the refracted ray, and the normal at the point of incidence all lie on the same plane. That simply means the incident ray, the refracted ray, and the normal at the point of incidence all lie on the same plane. Here is incident, here is refracted, and this is normal. Assuming this place is air and here is water, we have refraction. While the second law states that the ratio of the sine of angle of incidence to the ratio of the sine of angle of refraction is equal to a constant. I repeat, the ratio of the sine of angle of incidence to the sine of angle of refraction is equal to a constant, and this constant here is called the refractive index. Now we talk about the critical angle. It's the incident angle at which the angle of refraction is 90 degrees when light passes from denser to less dense medium. Dispersion of white light. This is the process or method by which white light is dispersed into its basic components. It can be done with a triangular glass prism. If this is a triangular glass prism and we have this to be white lights coming, at the getting to this point, dispersion of white light will occur. We'll have something this way: 1, 2, 3, 4, 5, 6, and 7, where we'll call it Roig Beeve. Roig Beeve, R-O-Y-G-B-I-V. The R there represents red, O orange, Y yellow, green, G green, B blue, I indigo, and V violet. When white light is dispersed into its components this way, we'll say that we have what we call dispersion of white light. Types of lens. There are two types of lens: the convex and the concave. Another name for convex is convergent lens, while that of concave is divergent lens. We have the principal axis of a lens, which is an imaginary line joining the center of the curvature of its surface. The optical center is a point through which rays of light pass without being deviated by a lens. The principal focus of converging lens is the point to which all rays parallel and close to the principal axis converge after refraction through the lens. The principal focus of a diverging lens is the point from which all rays parallel and close to the principal axis appear to diverge after refraction through the lens. The focal length is the distance between the optical center and the principal focus of the lens. Now here I would like to bring some equations in consideration since we started on refraction. The first, we have the equation of refractive index, which states that refractive index is equal to sine I all over sine R. Secondly, refractive index can be given as real depth. The D there represents depth all over apparent depth. Real depth over apparent depth, that is also refractive index. We also say that refractive index is equal to velocity in medium, velocity in vacuum, all over velocity in medium. This is also refractive index. Now, considering it with the critical angle we had, we say that refractive index is equal to 1 over sine C, where C is the critical angle. Now, before I take you over to optical instruments and their applications, I would like us to take a critical look on refractive index of triangular glass prism. Let me quietly put it here. Refractive index of triangular glass prism is given as sine half brackets minimum deviation dm plus the angle of the triangular glass prism A, everything here all over sine half A. This is the equation for the refractive index of triangular glass prism. Now pick up your past questions, write down the formulas, and see how well you can use them to solve all your problems. And in failure to do so, don't fail to contact Physics Clinic, Fusion Mobile Nigeria, or visit Sayudi through www.wunderbaik.com. Have a wonderful day.